Hello and welcome to 3D Straight Up, Episode 1, the show that teaches you 3D printing one mistake at a time. I'm your host, Joey Robier, and today we're at the 9th Annual Maker Faire to take a look at the new guys in the 3D printing scene. So come with me and let's meet the makers.
Hello, my name is Michael Curry. We're here at Maker Faire in the Bay Area. We're looking right now at my 3D printed vehicle creation. So it is a giant 3D printed attempt at making a full vehicle using just what I can make out of my two MakerBots. What you see here is about 2,000 hours of printing, about $700 worth of PLA. It is quite the creation. It's four-wheel drive with a drive system built entirely out of PLA. It's got front and rear axles. It's got a central transfer case. It's got differentials. It's got drive shafts. It's got CV joints, all made out of plastic. The one exception to 3D printing here is we ended up using real ball bearings, little, Delrin spheres, just because life's too short to make your own ball bearings.
My project is the Camera Sculptura. It's a massive photo array scanner. It's designed for instantly scanning people in 3D. It takes 68 pictures towards an inward volume, and I then use photogrammetry software to interpolate those into a 3D model. The resolution of the whole system is about a gigapixel. So you're doing about a quarter of a gigabyte of data at for every exposure.
Hello, I'm Savannah with Shapeways, and I am our shop owner coach, where I mentor all of the designers on the platform that are making and selling 3D printed products. So we have a variety of materials that you can print in. It's not just plastic. Over 40 different materials available on shapeways.com, including everything from full color sandstone, to gold-plated brass, to ceramics. And all of this is printed layer by layer through various different processes, and depending on the material, it's fired in a kiln or cleaned off and polished. Totally just depends. But we really encourage anyone who has 3D modeling skills to upload those STL files to the website, see how much it would cost to print in a variety of materials. We let you know if it's even possible right on the spot. Create your brand and start a shop and become the entrepreneur that you want to be.
Well, I'm Brian with Affinia 3D. We make a desktop-sized 3D printer. Very simple, small design, fully assembled product. Comes with a 1-year warranty. Did very well in Make Magazine's review of the desktop printers. Very simple process. Printer itself is very simple. It runs on ABS or PLA, plastic filament. Comes with a proprietary software that does the slicing of the 3D files. It's compatible with STL files, so it'll work with any of the 3D or CAD design programs out on the market. Very simple the way it works. Once your 3D design is sliced into layers, it takes the plastic filament, it goes through an extrusion head which melts the plastic, and then it layers down, or puts it down layer by layer. The Z resolution is 0.15 millimeters or 150 microns, so very, very thin layers. Price on this is $15.99. One of the key things I mentioned is it comes with a full year warranty, which isn't the norm in the desktop market. Most of the other options are maybe 90 days or 6 months. We're also backed by our parent company, Microboards, who's been in manufacturing for 25 years. And one of our successes is the fact that we have such a large technical support staff. So if an end user does have an issue with the product, they call in and they get a human being on the phone right away to help them figure out what the issue is. A proprietary software, so it's a program that we wrote. It works on Mac or Windows platform. One of the other things we kind of tout with the software is it's not open source. That's not always perfect for everyone, but we're trying to put out a finished product that's very, very simple to use, because at the end of the day, this is just an output device, and the real magic and the creativity happens in the design phase. And customers need something that they can take out of the box, plug in, and just have it work reliably for them as they're trying to work on their prototypes or whatever it is that they're making.
Hey, I'm Will, and I'm here with Form Labs, and we're showcasing the Form 1 3D printer. It's a high-resolution desktop printer that makes a really smooth finish and very high detail. And it does that by using stereolithography, which is this crazy process where we use a laser to cure a bed of liquid resin. And so that gives you really great parts As well, our printer is really easy to use. It comes with its own free software called Preform. You can actually download it today. And Preform takes your STL or OBJ files and actually generates supports on the fly for them automatically, so you don't have to know how to make supports, and then the printer will print it for you. The price of the printer is $3,299, so that includes our software Preform, which is free, includes the printer, of course, and includes a liter of resin as well as a finish kit. So you can actually print out a liter of product. So, you know, to give you an example, parts that are 1 milliliter cost 15 cents per part. So I can actually show you a part right here. So this part right here, I designed it to show you details. So if you look through the lens right there, I don't know if you can get a good shot of that. That's our worst layer resolution. That's 100 microns, and it's about as thick as a sheet of paper. And so 100 microns. So this part right here shows you our intricate details as well as our smooth surface finish. You can see half of our butterfly logo on that. And then that part costs about $1.50 to print. So it's pretty inexpensive as far as printing is concerned. And this takes about 2 hours to print as well. Formlabs has shipped about 1,000 printers. The printer comes with a warranty as well. So if you have any problems, you email us. And yeah, we're selling a lot. We used to have a really long lead time on the printer, and we were only taking pre-orders. Now we're actually shipping, and the printer is moving out really fast. So we're working really hard. We're making a great machine. We've upgraded the software about 9 times in the last year. In addition, we're working with some awesome people, and we have a contest going on. We're partnering with Shapeways to do the prototype to product contest right now. What that means is if you upload your design to Shapeways and tag it prototype to product, you can actually be entered automatically to win a Form 1. So the grand prize is a Form 1 printer and $500 of printing on Shapeways, and everybody who enters actually wins a $10 credit as well.
I'm John Oley from CMeCNC.com. We are a Northern Indiana-based 3D printer company, and we build some of the coolest Delta 3D printers out there. We've got our Rostock Max V2. It's our 2nd generation kit. And then we've also got our Orion Delta, which is the first to ship, all assembled, ready to print out of the box 3D printer. It has a 6-inch by 9-inch build volume. Works with ABS, PLA, PVA, T-glass, all of the Tallman nylons. Pretty much anything you can buy for a 3D printer is short of polycarbonate. We ship worldwide. We've got quite a few thousand machines out there now. We have one of the largest active Delta forums out there, forum.cmecnc.com. Stop by and check us out.
So my name is Brian Allen. I'm a co-founder of Smith Allen Studio. We're a small design firm based in Oakland, California, and we specialize in large-scale 3D printing and architectural work. So our project is to produce architectural scale prints that challenge traditional notions of what is possible using 3D printers. We've developed a software and hardware stack that allows the user to print architectural objects, partitions, and systems in their home. So this piece behind me is our prototype of a soon-to-be-released system for interior partitioning system. So imagine if you could print your own cubicle at work, if you could print your own space divider at home, and then on the fly, grind it back up and reuse it. So it really challenges what is possible using 3D printers for architecture.
Yeah, how you doing? I'm Braden from Robo3D. I'm the CEO. I just wanted to talk to you guys about some of the stuff that we're doing right now. We just kind of released the upgraded version of our R1 3D printer. That's what you're seeing over here. So this 3D printer is pretty much your all-in-one machine. It comes with a 10 by 9 by 8 build volume. It comes with automatic leveling. So every time you press print, it'll automatically level the machine for you, which is a pretty significant functionality with the machine. So we're trying to get it more of a plug-and-play type model. You know, it comes with LEDs. It lights up your printer. It comes with SD card functionality, so you can actually load directly to the SD card and kind of lose the cord. We're trying to get away from the cords as much as possible and not have it tethered. On top of that, we're getting ready in probably about 3 to 4 months to release our R2 machine, which is going to be more of our enterprise prosumer model. It'll have dual extrusion and some other features we're excited to launch. We're also launching our Makeable.com website, so we're trying to build an ecosystem around our company and our brand. Makeable.com is going to sort of a 3D file sharing marketplace, but what we're focusing more on is connecting designers and consumers in a freelance format. So if you're someone that has a 3D printer machine and you need something specific design, you can actually find a designer to actually design it for you for a pretty inexpensive cost. So we think providing all this functionality with our customers is going to be hugely beneficial, and hopefully we'll be able to, really build on this ecosystem.
So we introduced 3D Slash. 3D Slash is a design software for 3D printing. It's a very easy to use software actually, because once you have a printer, usually you need to be a CAD designer to make your own stuff. So we wanted to sort of avoid the barrier to entry of having design skills. So we made a very easy to use software, 3D Slash, that enables literally kids to make their own toys or you to repair parts. That's based on the initial idea is Minecraft, but instead of having one size cubes, you have multi-size cubes, and the lower size would be smaller than the resolution of the printer. So you can very easily, in a few minutes, you can actually start from a picture of the object you want to do. In a few minutes, we would design the object you want to do.
Hi, my name's Andrew. I'm from Type A Machines. Behind me you can see the Series 1, the 2014 Series 1, which is a very unique printer. It's offering a 12 by 12 by 12 build volume in an aluminium monocoque chassis. It's an incredibly reliable machine. The machines here have our next generation print head, which in 6 months of testing have seen 0 failures, including ones that you would have thought destroyed the print head, and they just keep going. The new print head is a unique all-metal design where the one part that you might conceivably want to replace is going to be able to retail for about $10. The machine is $2,300. The machine is also unique in that it's the only one offering an integrated web-based interface. So the machine is a networked machine. It's not a USB device. It supports both wired and wireless Ethernet. And it's, like I said, it's a web-based interface. So you just need a browser. You can print from your iPad if you've already sliced the file. So far we've tested the new print head with pretty much every material we could get our hands on. So PLA, high temperature PLA, flexible PLA, carbon fiber filled PLA, which is really exciting. We've also tested with ABS, nylon, polycarbonate, flexible materials of every single type, lay wood, lay brick, pretty much you name it, we've put it through that print head. And the limitation is going to be, if you want to print in the really weird stuff, you are going to have to add a heated build platform, because the print head doesn't care.
Hi, Brian Kwan representing Tier Time, makers of the UP 3D printer. We're showing 2 models here at the Maker Faire at the Bay Area. We've got the UP Plus 2, which is a brand new printer. It's got a self-calibrating leveler and a nozzle adjustment, which means that you have a very high success rate for printing. Both printers print ABS plastic, really high quality, durable ABS prints. The UP Mini has just had a price reduction, and it's $5.99 for a great UP Mini printer with a 4 3/4 inch build area volume, and it's running ABS and PLA, and it has a heated bed, and it's a great little printer for $5.99.
Hi, this is Shao Fan from Polymaker. We are at the Maker Faire at California. We are here with our new materials, Polymax POA, Polyflex. This is very flexible. And finally, our Polywood. Polyflex usually prints at about 220 to 230 C. No heated plate required, so it's very easy to use, and it's compatible with most desktop 3D printers. There's no curling, no warping. You don't need a heated build plate. It works really well and has very high printing quality. If you have followed us on Kickstarter, you will probably noticed that we have a new support material that we're going to release in the second half of this year. And we have one more product that's planned for the end of this year. And we will have more details on our website as well as on Kickstarter page.
Well, this is Petey the Parrot. I designed him last year. Hello. I'm not a very good ventriloquist, I'm a better puppet maker, but I modeled him in Maya 3D software and then printed him on an Affinia 3D printer. Gave him a lick of paint and put him together with some wires and a few springs and nuts along the way. And here we have my friend Petey. Say hello, Petey. Hello.
What resolution was he printed at?
Oh, a variety of resolutions, anything from 0.15 to 0.25, as I understand it.
We represent Buildtech. It is a ideal 3D printing surface, as you can see behind me. What we like to advertise that it will replace the need for blue masking tape or Kapton or hairspray or acetone slurry or all of those things that people are using right now. The sheets last a lot longer than masking tape or Kapton. They're a lot more durable. They're easier to install for starters. It's a lot harder to get an air bubble trapped underneath. And the best part is your builds will stick to it really well and come off really easy. With optimal use, it could last you for hundreds of hours. Optimal use, optimal settings. You just want to make sure the nozzle height's set just right, and you'll never go back to Kapton or blue masking tape again.
So yeah, this is our project, the Argus Geodesic 3D scanner. The idea behind it, it has 35 Raspberry Pis with cameras attached to them. Somebody comes in, steps inside, we hit a button, all the cameras fire at once, and then we use those cameras to feed back to our server where we extrapolate a 3D model. Right now the project is in kind of early beta stage, so we're having some issues with some of the components. We've like with the camera angle and the dense or the resolution, but we're working through those issues. And I expect we'll have a working product in the next few months.
All right, what we're doing today is we are demonstrating with our Velaman K8200 3D printer. Right now we are replicating this drive gear. The whole process from beginning to end takes about 34 minutes. The material we're using is a 3mm PLA. Our machine runs at 0.2 millimeter resolution and runs at a max speed at 120 millimeters per second. Some of the features of our printer: we offer a heated bed. We heat our bed at 60 degrees Celsius, and our filament is leaving the extruder at 190 degrees Celsius. This is our fan. What we have is a reduction nozzle on, concentrating all the airflow directly to the end of the extruder, which is curing the filament precisely right when it leaves the end of the extruder. This machine is all made of 80/20 aluminum. This is a kit. It's more of a mechanical build with some light electronics. There are some solder joints at the stepper motors and at the control board. You have two options when controlling this printer. You can either control via USB on your computer or with the standalone control module. So with the standalone control module, you load your STL files onto a SD card, which is communicating to the control board. So our maximum print size is 20 by 20 centimeters or 8 inches cubed. Everything on the table are some examples of some of the things we've made with our K8200. This has been on the market for about 12 months now, and we launched it last year here at the Bay Area Maker Faire.
This is a RepRap based printer. So the RepRap is basically an open source movement that pretty much based on the Prusas and the Mendels. This printer here, if you look at it, is pretty much laid out the same as a Prusa. It uses all the same electronics and software, open source software. The thing that's different about mine is and everybody does this, they all modify the printers to meet their design parameters. On this one, what I've done is I've replaced the frame with an acrylic frame that goes on the outside, and all of the guide rods are embedded directly into the plastic, into the frame. And they are not adjustable, so that when you put it together, everything is perfectly level and parallel. I've also, if you look at the axes, especially the X and the Y, they are controlled with a fast travel lead screw that will move, it will travel 1 inch per rotation. So it gives me about 2.5 times the resolution of a regular belt-driven 3D printer, and it allows me to build bigger as well. So I can make them. I've had them up to 19.5 inches per side of a cubic build volume. This one here is just over 1 cubic foot. It's a little bit slower than a belt-driven because you have additional friction because of the tension nut on the fast travel lead screw. So right now I'm printing at about 60 millimeters, and I've had it up to about 80, 90. I think I've even gone up to 120. Yes. So like on a typical belt-driven Prusa, for instance, with some G2 belts, you typically have about 54 steps per millimeter. This has 126, so it's roughly about 2.5 times the resolution of a regular one. The parts alone would go for about 1,700. With the plastic drilled and everything, the frame would be about 2,000.
Hello everybody, my name is Lucy and I'm the CEO of Feats, where we're making 3D printed shoes. These shoes are custom made to fit your feet and designed by you, so you never have to go into a shoe store and worry about what shoes are going to fit you again. We are asking people to sign up for our beta. Go to feats.co, where you can get some pairs of shoes to test them out so we can launch at the end of this year. Thanks guys.
This is Looking Glass, the world's first volumetric printing service. What we have here looks like me inside, but your eyes deceive you. Actually, it's just ink suspended inside a volume to give the illusion of a full 360 view version of me. And we can do all sorts of stuff with different transparency, like this frog. Again, there's no frog inside. It lets us make anything in the digital space come out into the real world. No requirements for being watertight, no restrictions on overhangs. Anything that can exist in digital space can exist in a looking glass. That's it. And we're launching a Kickstarter in about 2 weeks, where we're going to make some crazy new stuff like bioluminescent jellyfish.
iMaterialize is an online 3D printing service, meaning that you upload your file onto our website, you choose the material of your liking and the finish, and we ship it to you or to your customer. So I think what distinguishes us is the broad range of materials that we have on offer and finishes. We print in everything going from plastics to metals over ceramics. Can I take you over here to maybe zoom in on our new flashy ceramic colors? That is polyamide, the regular plastic. Over here we have some transparent resin in different colors. We also do multicolor printing. And over here we have silver, which is really popular. We have a huge community of jewelers. We offer silver in 4 different finishes, ranging from high gloss or premium silver to sandblasted, which is a very matte finish. We also print in titanium, so unpolished and polished titanium, brass, gold-plated and natural PU coated as a skull ring that you see there. And then stainless steel in different finishes, and high detail stainless steel if you really want to go for a lot of detail. Over here we have the resins. Prime gray, paintable resin, high detail, depending on what exactly you're looking for, whether you want to paint it or not, what level of detail you like. This is something really interesting. It's an articulated cube made by a designer called Kurt Plakke. He's a Belgian designer, and it's all printed in one go without assembly. He reinforced it with a few pins, but this is really, really impressive.
So my name is Alex. I'm founder of Rabbit Proto. This is my friend Rohan, and what we're doing is that we're making 3D printer print heads that don't only print plastic, but that also print conductive paste. So basically it allows you to print electronics, simple circuits, capacitive sensors inside the plastic objects. Have a demo kind of stuff that we're making. So it's a game controller, you print it in one step and it's functional. After you're printed, you just connect it to an Arduino and you're good to go technically to prototype with, for example, are the buttons too big, too small, stuff like that. So where we see this going is that right now we're using graphite paste, so paste from a company called Bear Conductive, but it's great. It's a great start for us because it's cheap, but we would really like to get some new exciting project applications. An idea that we have would be to embed an Arduino inside the 3D printed design and really get people's attention to get applications and see how far this can go. We really are at the tip of the iceberg and we're really curious to see where this thing can go.
How's it going, everyone? I'm Andrew Bergeri from FSL 3D and Full Spectrum Laser. I'm here with our Pegasus Touch laser 3D printer. Pegasus Touch is the newest laser 3D printer to hit the market. We're using a UV laser to cure a photopolymer resin, and what we're able to do is create parts with unprecedented accuracy and precision. We have an 80 micron spot size, and we can go with layers as low as 10 microns. And we're here at Maker Faire Bay Area meeting our customers. We had a Kickstarter, raised $820,000 in January, and we started shipping 2 weeks ago on time. So we're really excited to be here with everyone and really looking forward to seeing this printer get into the hands of more people.
What's the cost of the resin itself?
So the resin costs $100 a liter. And yeah, I guess I should mention the printer right now is selling for $27.50 for pre-orders. Pre-orders are going to be shipping starting in July. And after that, we're not really sure what the final retail price will be, but we're looking at a final retail of $34.99.
I'm Natalie from 3dkitbash.com, and we are toy inventors for 3D printers. And so we create the models that you actually print out on your own home 3D printer. And Quinn is actually one of our dolls that we created. She is online, and her model is $24.95 on 3dkitbash.com. And Quinn is from outer space, and she heard that the makers on Earth were really cool and that they would invent with her. And so she really wants a rocket pack and a helmet, and she wants a ray gun. She wants different styles of hair, and she wants swivel hips and things like that. So we're raising money on Kickstarter right now so that she can do mod kits and so that you can customize and modify her. So again, 3dkitbash.com. We also do test kits. So we have this test kit right here, and this one you can test spikes, overhangs, texts, tolerances, and whoops. So that's this kit here. So every 3D printer prints a little bit differently, and you want to see how different materials will print out too. So if you have a different kind of filament you're using, you might want to test it out on a small chip before you do a big project. And that was our first Kickstarter project, and that's on 3dkitbash.com for $24.95 also. And we also have Graphica, which is here, and this was our second test kit, and it's all about mechanical objects. So we wanted to make something that was nicely designed and would print in one piece, and that one piece would be mechanical. It would have a mechanical part. So this is the one that people seem to love the most. He's the ghost. And so he prints out in one piece on your printer bed, and he's mechanical, so he moves right off your printer bed.
My name is Zachary Schock. I'm doing a very large-scale 3D printing because I feel that the future of our built environment will be printed. So I'm trying to contribute to that conversation. So I built a okay-sized printer. It's called the Euclid Robot, and on the end of it I have an extruder, calling it Ron 2.1 at this point. It's filament fed. Sorry. It's not filament fed, it's pellet fed, which makes it fast and cheap. So I can pump a lot of material through it and print pretty quickly. So this is 2 5-hour prints for this wall. So the build area is actually bigger than this, but it's printed vertically and then printed vertically. And that's the idea is, if you're going to scale up for human scale, it can't take you months and months. I mean, it can, but nobody's going to pay for it. So why not just make it cheaper?
Hi, my name is Terrence Tam. I'm the designer of the open beam extrusion system, as well as the Casso Pro 3D printer that you see over here. So open beam is a scaled down version of a T-slot construction system used commonly in industry. We engineer for low cost for the maker market by using standard M3 nuts from the hardware store instead of proprietary T-nuts. And we use a lot of injection molding to bring the cost of the brackets down. So we've just launched a series of stamped metal plates as well. But what you're probably interested in here is the open beam Casso. This is a DeltaBot design. We developed this in conjunction with Johan Rojo out of Seattle, Washington at Matrix Create Space. And this is one of the first DeltaBot designs that's released into the wild. What's different about this printer is it uses 3 vertical towers, and it performs the mathematical conversion using a basically modified version of the Marlin firmware to convert rectangular coordinates to drive this printer. So we can use the same software toolchain as any of the RepRap printers. All the hard work is done in the firmware, and it's a interesting design because we can keep the end movement, the end effector mass very low, so the printer can do very high accelerations, high-speed accelerations without putting a lot of stress on the frame. These machines also have a really unique feature. If you were to look on the Pro, underneath the glass is a force-sensitive sensor. So at the beginning of each print, the printer will home up to find its starting position, then come down to tap the glass to find where the glass is, and perform automated bed leveling and height offset calibration to set the first layer properly. So if you ever run a 3D printer before, that is one of the hardest things to get right, and we've automated that for the user.
Yeah, hi, I'm Nick. I'm from PinShape, and we're building like next iTunes for 3D printing. It's kind of a mashup between Thingiverse and Shapeways. We approve all the designers because we know quality is important. We let you download files and print them at home, or if you want, you can order them from us. We'll ship them to your house in over 35 materials. We're just growing our community, so we'd love you to join. Take a look at pinshape.com.
Hi, my name is Brian Martinez. I'm one of the founders here at Made Solid, and we develop 3D printing materials, advanced functional materials for 3D printers. So we make two types of materials. One of them's here. It's a thermoplastic. Works with the MakerBot and Ultimaker, all the major filament-based 3D printers. With using our material, you can make things that are have more flexible strength to them, more transparency. It's more of an engineering-grade plastic. Our other material that we make are for SLA and DLP-based printers, like the Form Labs printer, for example. And so that comes in this bottle. But if you want to make something with more detail, like this this statue of Hank here, or if you ever want to make real metal parts, like we have inside this case, bronze, silver, gold, then you would want to use a printer like this. And so all our materials are proprietary, and we have more stuff in the works. So we're excited to be here at Maker Faire, and just wait to see what we have next year.
And we are a first, and so far the only, 3D printer company in New Jersey. We came all the way out here to show you guys what we've got here. What we are doing is we're selling our printers. This is our small model. Its build volume is only 1 cubic foot, so 12 by 12 by 12 inches. For us, that's small. That's our baby monster. We have other machines that are bigger than that. We have a machine that is 1.5 foot on the side, all square, so that's 3.6 cubic feet. And then we're going to have the real monster, which is 2 by 2 by 2 feet, or 8 cubic feet. The other thing that makes our printers a little different is that we have up to 4 extruders. So you can work with 4 different colors or 4 different materials. And the other thing that's different is that the printer is very modular, so that in the future, as we come up with more different kinds of extruders, you'll be able to add them on. And in fact, we're planning to offer a kit for you to make your own extruder if you're interested in adding innovative new technology to our machine. The kit will contain enough hardware to mount onto our mount plate and the control circuitry to hook up to your components, to your motors or sensors or whatever.
I'm Dan from Tinkerine. We're a Vancouver, BC from Canada based company, and we're down here at San Mateo this year to essentially show our new product, the Ditto Pro. The Ditto Pro is a continuing line of our 3D printer line, and it stems from our Ditto Plus, which got very well received on the Make magazine as one of the prices, best documentation, and runner-ups for best value. Going from that, we come out with a more elegant solution for the Ditto line printers, going from wooden cut a birch laser cut frame to an aluminum panel frame, CNC metal, and essentially injection molded parts. What you have here is essentially a very elegant printer, but that rivals some of the top-of-the-line printers in terms of quality, resolution, and build platform. The Ditto Pro that we have here is retailing for $1,900, and we're expecting to ship at the end of May.
We have our 1-up 3D printer and also a 2-up 3D printer here. It's the world's least expensive 3D printer at $199 for a kit. That includes everything you need to 3D print, including a small amount of filament. We also have the 2-up, which is $279. That's a 7x7x5 build area. And they're just as accurate, and we actually have some comparison prints to some other 3D printers over there, but they're just as accurate at 50 microns as some of the other leading printers. You get a lot lower cost, and that's mainly because we can buy in bulk. We manufacture everything in-house. We have a machine shop, so we make all the parts except for the electric motors.
Hi, I'm Andrew from Structured Printing. We're from Toronto, Canada, Waterloo actually, just outside, and we're creating an add-on device that will work with any existing 3D printer. So we're not trying to compete with a lot of these other platforms. We're actually trying to complement. So we've designed an extruder device that will allow you to print with almost any paste material. So to give you an idea, we've printed with icing sugar. Today, that's actually what we're printing with right now. Yesterday we tried some Nutella. Some other really interesting materials we've worked with are silicones from the hardware store. So this is extremely cheap, a couple dollars a kilogram instead of $40 or $50 a kilogram. And it gives you properties that are quite different than the traditional plastic filaments. So we're launching on Kickstarter in a couple weeks, and we hope you see us there. Thank you.
Hi, my name is Christian, and this is Zeus. This is the world's first all-in-one 3D machine. It doesn't just print, it also scans, fax, and copies. In addition, we also take out all the hassles of calibration and then parameter tuning. Everything is automated on a very simple user interface. So if you can operate an iPad, you can operate this machine. You also have a computer in the back, so you don't really have to plug in a laptop to operate this machine. We also have Wi-Fi connectivity, so that if you want to download things from outside world, you can do that very, very easily. That's it.
What's the price point?
Right now it's $2,500. However, we also have a Maker Faire special of $500 off, and we also give you some filaments for free.
Hi, my name is David, and this is my colleague also, David.
Hi, I'm David.
So David, can you tell us something new about our amazing printer?
Yeah, definitely. Our printer is called D-Green. We are a company which is called B3D. We are from Europe, and right now we have an office in San Francisco. This is absolutely amazing product because it's cheap, and with great resolution of models. The price is $2,000, and we are able to print objects like this. If you like, please follow us on the Twitter and Facebook.
Hello, so my name is Nora, so I'm presenting Sculptor. So Sculptor is an online 3D printing service. So what we do basically is to print for you. We do use only professional grade printers. We provide about 50 different materials and finishes available directly online. So we're a French company based also in San Francisco. So we are now local. And so we provide from plastic to ceramics to resin, alumide, sterling silver, wax, and then we can polish, paint, dye, coat, etc. So if you have a CAD file, all you have to do is upload it on the website, and then you can place your order directly online.
So Shapify is a free program that you can download and use with your own Connect at home, and it lets you scan people in 3D, and it's a one-step process to just send it to Sculptio, and they will print it out for you and ship it to your doorstep. So you'll get a little figurine in the mail. And also we have a showroom in Palo Alto where you can visit, and we do so much more. We can do custom printing, we can do 3D modeling for you, and we also have our professional scanners as well, which do much higher resolution.
Hi, I'm Kim Losi from Madio 3D. We're here at Maker Faire. This is the Madio booth. It's a brand new app we launched this week for the iPad that allows you to customize and create your own creatures and then print them directly on your 3D printer. You can choose different parts. You then apply color, texture, whatever you want. You modify them, you press print, and it will lay it up directly on the print bed for your 3D printer. Everything's been designed to minimize material usage and print with no support materials.
My take on a 3D printing thing is the plastic printers, I wouldn't trust my life to anything that comes off of the printer. It makes a lot of good stuff. I mean, they solve a lot of problems, make a lot of cool models, but I have a lot of experience with welding, and I kept looking at them, and they look like welders to me. They're working with plastic welding rod and going layer by layer. So the idea here is to create a machine that extrudes metal wire and welds layer by layer. So in the end result, I'll be able to make something that is substantial. And of course there are metal printers out there, but they end up being sort of high-end machines, and I'm not looking for that kind of resolution here. Although I think it will give us some good resolution, what I'm looking for is the strength, stuff that I can calculate and know that we can make some solid engineered things with. get it to near net, and then machine it. And ultimately for me, I want to scale this machine up much larger and make public art and take this machine to the site, turn the welder on, and have the welder and the whole process solar powered, because these welders nowadays, the inverter style welder, don't consume a lot of power. You can find some good powerful machines, good results, that plug into a wall. So getting solar powered welding should be a piece of cake. And then make these public art pieces on site where people could come night and day and watch the process, and then when it's all done, you take the machine away. I think it would be a fascinating, artistic, media way to do things. So.
About how much do you spend putting this all together?
Well, I think that it's low cost. The drive board itself is $130. All the stuff that, shipping, what have you, maybe $150. The drive motors are $20 drive motors. The frame structure is mild steel tubing, which is $20 per foot. But that's not to say that this is not an accurate, robust machine. I think this is more accurate and more robust than a lot of the 3D printers that are laser cut wood or laser cut acrylic, those kind of things. This is actually a welded steel structure. So I'm sure it's quite sturdy, and I know the accuracy is right on the money. So.
Do you have videos of it operating on your website?
I only have the motion controls, but I don't have any videos of it welding at this point. I'm still in the stage of trying to integrate the software with the welding process. The welding process is enough different that I'm pushing all the slicing software to its maximum, and I'm actually having to go back through and clean up the end results so that I can match it to what my machine wants to do. So I'm sort of hoping I'll bump into a software partner by being here at the show. And I've also had some problems with the TIG welding process that this uses. Creates a high frequency surge on every startup, which is freaking out the drive board. And so I have to figure out how to solve this high frequency radio wave problem. I think I did find somebody by coming to the show to help solve this problem. Somebody I would not have met any other way, so I'm quite grateful for that meetup. Anyways, very much in the infancy, and hopefully it'll work by next year.
Well, that wraps things up for our first episode. Apologies to those at Maker Faire I couldn't get to. Trying to find specific booths was kind of like finding fly shit and pepper. Feel free to email me your comments at joey@3dstraightup.com. And if you're in the Los Angeles area and want to be a co-host with me, send me a 30-second video of yourself explaining 3D printing without using the words tea, Earl Grey, hot. Join me next week as I give you a primer on the different methods of 3D printing, and also as I do a rundown on the different platform materials that you can print on to make your print stick. Until next week, see you then.